Good day, everyone. My name is Susana Ngula. I am a BTech quality student at Cape Peninsula University of Technology. Today, I'll be presenting the 4 types of data in relation to quality management. But firstly, I would like to introduce you to my group members who equally contributed to the compiling of this presentation. Firstly, we have Fandeso Zinhle. Secondly, we have Mbombo and C.U.Y.F. Thirdly, we have Mbula Sandisiwe. And lastly, we have Manchingana Ziyanda. The following is our outline, which will give a brief summary on the points I am going to present today. Firstly, I will be introducing you to statistics. Explain how statistics is used in quality management. Explain how the PDCA cycle uses data. I will also introduce you to data. Give a brief summary on the 2 branches of statistics. Discuss the 4 types of data in detail. Compare these types of data to each other. And lastly, I will conclude. What is statistics? In our daily lives, we come across numbers, but sometimes it is not easy to make sense of what these numbers mean. This is where statistics comes in. Statistics is the collection of mathematical techniques that help to analyze and present data in a manner that is understandable by everyone. In simple words, it is a tool organizations use to convert numbers into useful information so that good decisions are made. The organization also uses statistics to improve quality. This takes place in many forms, including but not limited to design and analysis of experiments through planning, conducting, analyzing, and interpreting control tests to evaluate the factors that may influence a response variable. Statistics in quality management. Edward Deming, whom is a quality guru, applied the PDCA cycle to reduce excessive variability in processes and products by using statistical tools. The PDCA approach towards quality management is a continuous approach, so organizations continuously use the PDCA cycle to improve their processes so that they are able to increase the quality of their products. Increased quality leads to increased customer expectation, which in turn drives further product and processes into improvement. This is a picture I got from asq.org, which shows an example of a PDCA cycle. As we can see, it happens in 4 stages. I will be explaining how the PDCA cycle uses data. On the first quadrant, we have the plan stage. This is where you identify the problems and objectives of your study. In the second quadrant, we have the do stage. This is where the practicality happens. In this stage, we collect data for analysis from customers. This can be done through surveys and experiments. On the third quadrant, we have the check stage. This is where we analyze the collected data and compare the actual results against planned objectives to measure customer satisfaction. On the last quadrant, we act. This means we fully implement what was planned in order to improve processes. Corrective actions through the PDCA cycle. After you have collected data and analyzed the data, you will be able to identify the problems and eliminate the causes. Take necessary actions based on what you have discovered in your study. You will be able to standardize the process and implement it across the business. Lastly, you get to plan again for continual improvement. On the right-hand side, we have a picture from jannex.com. It shows clearly that the PDCA cycle is a continuous improvement. Data. What is data? Data is the different values that we obtain from trying to measure a particular variable. The data shown below are mark scores on 5 different tests conducted in 5 weeks. This data helps us to compare his scores and learn his progress. There are 2 types of data: primary data and secondary data. Primary data is the data we have collected ourselves. However, it is time-consuming and expensive. Secondary data is the data we are borrowing. It is the data that is collected by someone else, but we are using for analysis. Data collection. To understand data collection, there are 2 terms I need to explain. That is, a population and a sample. A population is all the possible items, units, and members of a certain group. However, it is not possible or practical to measure data for every element of each population. Therefore, we have a sample. A sample is a smaller subset or proportion of a population that is approximately a representative of the larger group. This picture from keydifferences.com shows the difference between a population and a sample. As I have said, a population is the entire members of a certain group, whereas a sample is just a representation of this population. Remember, ethics is important. The sample has to be a true representation of the population. In other words, a sample is the group of individuals who will participate in your study, and your population is the broader group of whom your results will apply to. There are 2 types of branches of statistics. Firstly, we have inferential statistics. Inferential statistics uses a large variety of techniques that allows us to make claims about a population based on a sample data. Remember, your sample has to be a true representation of your population so that we can make valid claims. An example of inferential statistics would be if I said 67% of students have Candy Crush game on their phones. Secondly, we have descriptive statistics. It summarizes and displays data to quickly obtain an overview of your study. An example is an average class mark. There are 2 types of descriptive statistics: qualitative data and quantitative data. Qualitative data uses textual terms to measure a variable of interest. We do not need to convert it into numbers in order to analyze qualitative data. Quantitative data uses numerical values to describe a variable of interest. Within the field of quantitative data, we find 4 types of measurement scales. This illustration shows that the 4 types of data can be categorized into categorical and numerical data. Under categorical data, we have nominal data and ordinal data. And under numerical data, we have interval data and ratio data. I will be discussing the 4 types of data in detail. Firstly, we have nominal data. In statistics, nominal data, also known as a nominal scale, is a type of data that is categorized or labeled without providing any quantitative value. Nominal data cannot be ordered and cannot be measured. Examples of nominal data include words, symbols, names, and nationalities. In order to analyze nominal data, you have to do counts, as you cannot analyze it directly. This is a practical example of how to apply nominal data in the real world. This is a summary of data taken from Extended Kibbles, a company that sells cat food. In this data, the different problems are categorized in terms of alphabet so that the company can see how many problems they encounter due to the same cause. I will be taking you through on how this is done on Excel. This is the raw data where it is clearly explained what each alphabet represents. For example, A represents any problems associated with nozzles. The COUNTIF function is used to categorize data. This is done by first entering the equal sign to let Excel know that it is a formula that you want. You then search for the COUNTIF function. You double click. The function prompts me to select my range. This is the data I'll be doing counts on. After selecting my range, it prompts me to input my criterion, which is the type of problem that I want. Remember to use inverted commas for any alphabets or complex operation. The final answer is 8. This means there are 8 problems the company is facing due to nozzles. Secondly, we have ordinal data. Ordinal data consists of nominal data characteristics, but it is ranked data. Ordinal scales are typically measures of non-numerical concepts like satisfaction, happiness, and discomfort. We cannot perform mathematical operations using rankings, but it does give us more information than just categorizing the data. The following is a Pareto chart, which is an example of ordinal data. It ranks the types of problem a company is facing and in what order they need to address them. Thirdly, we have interval data. Interval data cannot be multiplied or divided. However, it can be added or subtracted. Interval data doesn't have a defined absolute 0 point, which is present in the ratio data. The lack of absolute point 0 makes comparisons of direct magnitude impossible. An example: it is not reasonable to claim that one student is twice as knowledgeable as another is, because he or she happened to earn an exam grade twice as high as the other did. Lastly, we have ratio data. Ratio data is regarded as the king of the data types. It has a true 0, which means we can perform all mathematical operations, that is, addition, subtraction, multiplication, and division. Examples include 3 kilometers is twice as much as 6 kilometers. 15 kilograms is half of 30 kilograms. Other examples include time and height. This data has a true 0. In the absence of any, there is nothing. The following table shows the different methods of analysis that can be used to differentiate between the 4 types of data. The method of analysis that I used are frequency, median and percentiles, the ability to add or subtract, the mean, standard deviation and the standard error of the mean, and the ratio. The ticks show the characteristic each data has with respect to the method of analysis. I can therefore conclude, based on implementation of the PDCA cycle, we can extract data, analyze and use the statistics to make good decisions for continuous improvement. This in turn increases customer expectations and drives further product and processes into improvement. Companies use statistics to eliminate variation to improve quality. Through statistics, an organization is able to monitor and measure its processes. I would like to thank you for lending me your ears throughout the presentation.